Let's continue with the Kubernetes objects in this video. Next topic is the Kubernetes object management. The command line tool kubectl supports 3 different ways to create and manage Kubernetes objects: imperative commands, imperative object configuration, and declarative object configuration. Imperative commands operate directly on live objects in a cluster. Examples are as follows: kubectl run nginx using the latest image of nginx, and kubectl create deployment named as nginx and again using the latest nginx image. Both of these commands do the same action, which is to run an instance of the nginx container under a deployment object. Commands are simple, easy to learn, and require only a single step to make changes to the cluster. On the flip side, there isn't much control provided while creating the object. Commands do not provide a template for creating new objects, nor is there any audit trail created for the changes made. Next is the imperative object configuration. In this type of object creation, we need to specify the operation with the kubectl command and at least one file name which contains full definition of the object in YAML or JSON format. For example, the command kubectl create -f config1.yaml creates the objects defined in a configuration file. Similarly, kubectl delete -f config2.yaml deletes the objects defined in the configuration file. On the similar lines, replace command with kubectl updates the objects defined in a configuration file by overwriting the live configuration. Object configuration can be stored in a source control system such as Git. It is simple to share and easy to understand. It requires an additional step to create YAML files, but it also provides us the option to consolidate all the customizations and specifications in a single file. This is the most common way to create objects in Kubernetes, and we will use this method a lot in this course. The last method is the declarative object configuration. When using declarative object configuration, a user operates on object configuration files which are stored locally. However, the user does not define the operations to be taken on the file. Create, update, and delete operations are automatically detected per object by kubectl. This enables working on directories where different operations might be needed for different objects. For example, we have a configs directory which has multiple object configuration files. We can use kubectl diff to see what changes are going to be made, and then we can go ahead with applying the changes using kubectl apply command. On the plus side, this method has better support for operating on directories and automatically detecting operation types per object, that is whether to create, update, delete, or leave the objects untouched. However, it is harder to debug and understand results, especially when they are unexpected. Next topic that I want to cover in this video is about objects names. Each Kubernetes object in the cluster has a name that is unique for that type of resource within a namespace. What it means is that you can only have one pod named, let's say, WizLabs within the same namespace, but you can have one pod and one deployment that are both named as WizLabs within the same namespace. Two different namespaces can have a pod with the same name. Every Kubernetes object also has a UID that is unique across the entire cluster. That's the UID of the pod which we had created earlier. Kubernetes resources can have names up to 253 characters long. The characters allowed in names are digits 0 to 9, lowercase letters A to Z, hyphen, and dot. Once an object is deleted, we can make a new object with the same name. Let's get into some details of namespaces. We know that namespaces are intended for use in environments with many users spread across multiple teams or projects. Using resource quotas, namespaces are a way to divide cluster resources between multiple users. We can specify the resource limits per namespace, and we will cover this in detail in the upcoming videos. Namespaces provide a scope for names. Names of resources need to be unique within a namespace, but not across namespaces. Namespaces cannot be nested inside one another, and each Kubernetes resource can only be in one namespace. We can get the existing namespaces by running the command kubectl get namespace. Kubernetes starts with 4 default namespaces, and the 5th one we had created as part of the first section of this course. The default namespace is for the objects with no other namespace. kubesystem, the namespace for objects created by the Kubernetes system. kubepublic is the namespace mostly reserved for cluster usage, in case that some resources should be visible and readable publicly throughout the whole cluster. The kubnode lease namespace contains lease objects that are used by kubelet to determine node health. Kubelet creates and periodically renews a lease on a node. The node lifecycle controller treats this lease as a health signal. While creating a new object, we can specify the namespace in which we want that object to be created in. Or we can set the context and save the namespace for all subsequent kubectl commands in that context. To set the namespace for a current request, like creating a pod, we need to use the namespace flag. In the object configuration method, we need to mention the namespace in the object YAML file. Using this command, we can permanently save the namespace for all subsequent kubectl commands. We can create a new namespace by running the kubectl create namespace command. So the namespace got created. We can also look for pods within a particular namespace. If we don't specify any namespace, it takes the current saved namespace in the context. By default, it is showing the pods in the default namespace. We can also confirm this by mentioning the namespace name in the command. We can also mention the command in short form as -in. Here we have listed the pods in the kubesystem namespace. We can also look for objects across all namespaces. Also check these services across the entire cluster. Most Kubernetes resources, example pods, services, replication controllers and others, are in some namespace. However, namespace resources are not themselves in a namespace, and low-level resources such as nodes and persistent volumes are not in any namespace. Let's see which Kubernetes resources are and which aren't in a namespace. I'll run this command to see the resources which are in a namespace. Similarly, I'll run this command to see the resources which are not in any namespace. These include nodes, namespaces, persistent volumes, etc. That's all that I wanted to cover as part of this video. To summarize our learning, we understood the Kubernetes object model, the status of pods, and the containers within the pod. We did an overview of the different approaches for Kubernetes object model, that is the ways to create and manage the Kubernetes objects. We also covered the namespaces and the object names within the cluster.
For more details, check the link in the description. Learn with Wits Labs. Success certified.